Today we're going to be covering monomials, and we're going to start off with the definition of a monomial. And a monomial is an expression that is a number, a variable, or the product of both. Remember, the product means multiplication. The product means multiplication. So here some examples are a, 34, a times x, or 25 times a times x, or 31 times a times x squared. A non-example, we cannot divide by a variable in a monomial, so a divided by x or a over x would not be an example of a monomial. Constants. Constants are monomials that contain no variables, or in other words, they are just numbers. Constants are just the numbers. Coefficients. Coefficients are the numbers that are in front of the variables. So, for example, for x, the 4 would be the coefficient. 52x, 52 would be the coefficient. Here we just have a b, but what number is in front of the b? A 1. So this coefficient is 1, and negative t, what kind of coefficient do we have? We have a negative 1 in front of the t. Now, the degree of a monomial is the sum of the exponents of the variables. Sum of the exponents of the variables. Here we have x squared. The sum of the exponents is 2. Here we have x cubed, y squared. How many exponents do we have? We have 5 total. Now here we have to be careful. How many exponents are on that b? We have 1 there, 2 on the c, so we have 3. That 4 is a constant, so that has no exponents that we are going to count. Now we're going to simplify some terms, starting with 3n plus 2n. Remember, we have n and n, the same like term, so this is going to be 5n. And I'm going to break it down here a little bit when we get bigger variables. I like to treat these like fruits. So here, a cubed b, I'm going to make an apple. So we have 4 apples plus 11 apples, and then we're taking away one of those apples, so that's going to give us 14 apples, but we're not counting apples, we're counting variables, which is a cubed b. Next, using apples, I'm going to let my x squared be apples. So I have negative 5x squared apples, and I also have a minus 4 apples. Now I'm going to take my x's and let them be bananas. And I have 7 bananas over there. So now if we total up our apples, I have a negative 5x squared apples here, or minus 4 apples here, so I have a total of negative 9 apples, and instead of apples, I'm going to put my x squared. Now how many total bananas do I have? I have a positive 10 bananas, so I put positive 10x. And for one more down here, we have xy, xy, and here we have a yx, but it's the same thing as a xy thanks to the commutative property, because what's 3 times 4? 3 times 4 is 12. 4 times 3 is still 12. So here we can still take away this 2yx. So here we have 9xy minus another xy, just looks different, and so that's going to give us a 7xy, and then minus y. Now we're going to get into the fun stuff, and I'm going to start here. Now we are multiplying an r cubed times an r to the 4th, and here r cubed gives us r times r, while r to the 4th gives us r times r times r times r. Now how many total r's do we have? 1, 2, 3, 4, 5, 6, 7. So r to the 3rd times r to the 4th is r to the 7th. What did we do with the 3 and the 4? Well, we added. And here's the definition. When we are multiplying any numbers, we are going to add the exponents. So we have to multiply the same numbers, and we add the exponents. And that's just written mathematically. Next example here. We have to keep our same number or our same variable. Well, here we have 3 of them. 3 of them we're multiplying, so we get a to the 6th. Here we have b to the 1st, b to the 2nd. We add them up, so we get b to the 3rd. Next, we have d to the third, all raised to the fourth power. Now we have to think about what this means. What does that mean? We have d to the third how many times? 4 times. So we have d to the third, d to the third, d to the third, and d to the third. So how many total guys do we have? Well, we just learned that when we multiply, we add our exponents up. So here we're going to add them up. 3 plus 3 plus 3 plus 3 is 12. So we have d to the 12th. What do we do with the 3 and the 4? We multiplied them. See if I can get that to come up. We multiplied them. So again, just by definition, if we have a to the nth to our n, we're just multiplying our exponents together. And for one more example with number 7, here we have a to the second all to the third. Notice how the third is outside the parentheses. So I'm going to write this as a to the 6th. Again, we are multiplying. We are multiplying. Now, here, I'm going to start off with another example. How many xy's do we have? Well, we have xy times xy times xy. Using our past examples here, how many x's do we have? Well, we have x to the third, y to the third. So what did we do with this 3? We put the 3 to the x and the 3 to the y. So that example leads us to the following definition. For any real numbers a and b and positive integer m, where we have m outside of the parentheses, we have to take that inside the parentheses to both the a and the b. So let's try it with example number 9. So we have a 2 that is outside the parentheses. I'm going to take that to the 4. I kind of missed the 4. So it's going to be 4 squared. And I'm going to take that 2 to the 5. Remember, when we have an exponent to an exponent, we multiply. So it's going to be y to the 10th. And here with 10, again, this 4 goes to the 3. So that's going to give us 3 to the 4th and a to the 8th because we multiply. Now we can rewrite 3 to the 4th as 3 times 3 times 3 times 3. So 3 to the 4th is 81 a to the 8th. Now we're going to simplify these guys. Now they look tough, but let's keep in mind our definitions, our properties. So we're multiplying these two guys together. So we have 3 times -5, which gives us -15. We have a cubed times a squared, but when we multiply exponents, when we multiply variables, we have to add the exponents, so we get a to the 5th. And now we have b times b squared, and that gives us b to the 3rd. With 12, I'm going to rewrite this first. It's kind of hard to see here, but I'm going to take this exponent that is outside of, the exponent that is outside the parentheses, and take that to what's inside. So we have to multiply our exponents to get x to the 6th, y to the 6th. But I still have my x to the 4th, y to the 4th. So now, when we multiply these guys together, we add the exponents to get x to the 10th, y to the 10th. And one more here. If I multiply all these guys up, I'm going to have a -4 times this negative to get a +4. And then how many a's do I have? 1, 2, 3, 4, 5, 6. So I have a to the 6th minus, now I'm going to write this guy here in red. We have a -3. And now how many a's do we have? 1, 2, 3, 4, 5, 6. So I have a to the 6th. Do I have the same kind of fruits? I sure do. So I get a to the 6th. How else can I write this? I can write this a to the 6th. Next, we're going to jump to scientific notation. Scientific notation is defined as number is in scientific notation when it is in the form of this, where it's a number times 10 to a certain power, where we want our a to be between 1 and it has to be less than 10, and n is an integer. So now when we have a big number, we want one number to the left of the decimal. So I'm going to put one number to the left of the decimal. Now remember the decimal started back there, but to move it I went 3, 6, 7, 8. So I have 2.46 times 10, and how many times did I move the decimal? I moved it 8 times. And I'm going to jump to number 16 here. So that's a big number. We have a positive exponent. Now for a small number, we still have to do the same thing. We have to move the decimal so we only have one number to the left of the decimal. And now how many times did I move it? 1, 2, 3, 4. So I moved it 4 times, so I'm going to take it times 10. Now it's a small number, so it's times 10 to the negative 4th. Now finally, we come up with something like this. Now it's the same way as we multiplied our monomials. I'm going to take 3 times 1.9, and that gives us 6.08. And now I take 10 to the 4th times 10 to the 2nd, and when we multiply the same numbers, we add the exponent, so it's times 10 to the 6th. And it is in scientific notation because we have one number to the left of the decimal times 10 to the 6th, so we are good. And that concludes lesson 5.1, monomials.